right, folks, I wanted to give you some examples of the questions I want you to be looking at. And so one of the things we're going to be working on this week is how to use the unit circle to sort of find these angles, or vice versa. If I have the angle, how do I find the ratio? And so hopefully you watched the Khan Academy video before this, which is sort of explaining what the unit circle is and what it tells us. But I wanted to look at just an example of some questions like the ones I want you to do in the homework. So here I have the unit circle, and pretend like I'm an excellent artist or whatever, and these are all the same triangle. They're not, but pretend they are. And so we're gonna say like theta 1, that's this guy right here, and he's a turn of 45 degrees. And then here's theta 2, and he's 135 degrees. And then theta 3 is down here at the next 45 degree interval, which is going to be 225. And then the last one here is 315. So hopefully you remembered from the video that the x of each one of these, the x, is going to be our cosine, and the y of each one of these is going to be the sine. So each one of these guys right here, the y value is the sine. So we don't necessarily care about this length per se. We know that this length in each instance, if you're going from here to here or from here to here, we know that length is positive. But the point itself is what we're going to define, excuse me, as sine or cosine of that value. So here, every time I'm looking at this point, the y's in this whole corner are going to be positive. And if I'm looking here in this quadrant 2, the y's are always positive. And here, the y's are always negative. And here, because we're below the y-axis, the y's are once more going to be negative. So we're always going to be making sure we're thinking about that when we're thinking about dealing with the unit circle. Now, if I have something like these down here where we know what this is, let's go ahead and figure out what the ratio for these angles are. Now that's going to be the easy part, because our calculator is just going to play along. It's going to play nicely. So, come on, wake up. So I already did it for you here. So maybe you can see it. So the sine of 45 is 0.707-ish. And then 135 is 0.707. They're the same. That seems like it could be problematic. And then down here, we have the sine of 225, and it's negative 0.707. And then here, it's negative 0.707. Okay. And the reason that those are all sort of similar, but not exactly the same, right? These two are the same and these two are the same, is because in each one of these instances, we're talking about a right triangle where in each one of these, even though the turn is 315, this angle right here is still 45. This little angle right here, 45. This little angle right here, 45. This angle right here, 45. So if we break it down into just the simplest version, into just a little triangle, this is 45. And because it's the unit circle, the hypotenuse is always 1, which means that for each one of these, the opposite side of our angle is always going to be approximately 70.7% of whatever this guy is. So that's that what is a trig ratio thing. So this guy will be this portion of whatever this one is. So that makes sense because each one of these triangles are basically the same. And then these two are negative because these coordinates are negative. So we're going to see if we can backwards track. So we know that the sine of theta 1 is 0.707 and the sine of theta 2 is 0.707. And then 3 is negative 0.707 and the negative 0.707. Okay, so let's see if we can use our calculator to backtrack and figure out what that is. Okay, so come down here to the bottom. We're going to go Control I'm not sure if you can see it there. And I hit trig. Oop. Try again. Trig. Sine inverse of 0.707. And it's going to give us 44.99. So approximately 45. That's because of the rounding issue, right? So 45 degrees. Okay, great. That's what we expected. And then, all right, let's do it again. And it still gives us 45 degrees. Well, I mean, clearly it wasn't going to give us a new answer. We punched the exact same thing in. But we know that theta 2 isn't 45 degrees, right? We know that it's over here. So how can we use the knowledge we have and the calculator's response of 45 degrees? It told us 45. We know that's not true. But how can we use that to figure out what theta 2 is? Well, it told us that for the triangle that it's thinking exists, 45 degrees, that this guy right here, here's the triangle we told it about, 45 degrees. But we know you had to go from here all the way over. That's how we've defined the unit circle. So if you think about this as backward planning, we've gone 45 degrees prior to 180, right? So if you take 180 degrees and you subtract 45, you get 135. And that's from thinking about the 180 minus 45. It's the backward turn. Okay. All right, let's try it again. Let's see if the calculator can figure out negative 0.707. Okay. Okay, so there it says that the inverse sine of negative 0.707 is negative 45 degree angles. Okay, well that might melt our brain a little bit. So it's telling us it's negative 45 degree angles. Well, thank you very much, calculator, very helpful. So negative 45 degrees, great. What did the unit circle guy tell us? Well, he told us if it's a negative, right, then that means it's like a backwards turn. So the calculator is thinking it's a backwards turn of 45 degrees. So it's thinking that it's a backwards turn of 45 degrees. Okay, it's thinking it's that guy right there. So a backwards turn of 45 degrees is basically 45 degrees before we go all the way around 360. So what's 360 minus 45? Well, it's 315. So we're basically using the calculator there to figure out that this guy is 315. So we have to use a little bit of reasoning here, right, to figure these out. This last one, look, exact same thing. The calculator's not going to spit anything different out. It's still going to tell us negative 45. So we know that it's negative, right? So we know it either lives here or here. We figured this one out. So if these two triangles are exactly the same, then this negative turn right here, that must be the same triangle as this one right here, right? So this one's 45 degrees on 180. This one's 45 degrees prior to completing 360. So this guy's going to be, it's going to be 180 degrees plus 45, which is 225. Cool beans. So we were able to figure that out. So it's not as easy as just punching it into your calculator when it goes the other way. That's why I wanted to make sure we looked at these as a group. So I'm going to show you one that's going to be more like what the homework is. So I'm going to tell you the cosine of theta is 0.52. What could theta be? Well, the first thing we want to look at is the fact that 0.52 is positive. Where is cosine positive? Well, cosine is the x one, and x is positive here, and x is positive here. So we know it's going to be somewhere over here. It's going to be a triangle either in here, or it's going to be a triangle in here. Basically the same triangle, but two different ways, right? It could be theta, or basically the opposite of theta down here. So let's go to our calculator. and we're going to say, all right, handy dandy calculator, we're going to do inverse cosine of 0.52, and it tells me 58.7. So we know that this little guy, the first response is 58.7. So it could be that. Theta could be 58.7, or it could be going all the way around. Do you like my motor noises? All the way around to 360 degrees minus, basically, but not this part, 58.7. Okay, that's going to be 301.3 degrees. Sometimes you might see this angle right here written as just negative 58.7, right? Those two are the same thing. It's talking about the same point, this point right here. So these two guys are the same location, so it's the same theta. This guy's a different location, so it's a different theta, okay? We're gonna do another one here. This one's gonna be the tangent, and the tangent is negative. Cool. I thought we were only talking about sine and cosine. So what I did is I went back up here and I said, we know from all those funny little gifs about tangent or tan lines and things like that. So the tangent of theta is sine over cosine. And the guy in con did talk about why this makes sense here, given the definitions we have. So the tangent is sine over cosine. So it's going to be sine over cosine. We don't really care about that right now. All we care about is whether it's going to be positive or negative. So in this corner up here, a positive over a positive is going to make this guy positive. In this corner right here, a positive over a negative is going to make tangent negative. Down here, a negative and a negative is going to make this guy positive, right? Because like negative over negative makes positive, like in a fraction. And then here we have negative over positive, which means here, this guy's going to be negative again. So, right, we know this guy, right? We have negative, negative. So we know that this guy right here lives either somewhere down here or somewhere up here, right? It's going to be something like that. And those two triangles would be basically the same triangle if we looked at them, kind of, right? It's a rotation of each other. So let's go to my handy dandy calculator and see how wildly off base my calculator is right now. Maybe he'll only be half off base. Okay, so let's go trig tan inverse, because we want to know what the angle is. 0.523, oops, make it negative. And then click enter, and it tells me negative 27.6. Cool, thanks, guy. So it tells me theta is negative 27.6. All right, so how can I turn that into something that's actually understandable? Well, that guy is like a backwards turn, right? So that one's the same as the 360 minus 27.6. Oops. Which is 332.4. So there's one place it could be. That would be if it was this one, right? There's the first option. The other option, right, is over here. We'll call this guy theta 2. So this theta is the one they tell us. Now, you kind of have to think back a little bit to geometry, right, with alternate interior angles, or not, that's not the one, vertical angle theorem, right? We've got this guy and this guy making a pair of congruent angles. So it's this one and this one that are the same. So if this is 27 degrees right here, this little triangle, then this guy's got to be that same 27 degrees. So this guy, little corner right here, is 27.6. So we're being flexible with our numbers here because we have to be flexible. But theta isn't 27.6, right? Theta is defined as from here to here, right? what is that? So theta is going to be 27.6 degrees short of 180. So we'll go 180 minus 27.6 gives us 152.4. 180 minus 27.6 equals 152.4 degrees. And all of these have been done in degrees here. Okay, so on the homework, sometimes I'll tell you like, here's the ratio and it's in quadrant number 2. And so you'd say, oh, it must be this one. It's not this answer, it's this answer because of the included information. But that's a lot like what the homework's going to be like. So I want to make sure you understand how we do those. All right, guys, so those are the explanation for this assignment.